Okay, so let's see if I can get this done fast. I want to go and practice my life. So, all right, so I'm gonna lower that. So we had, you guys agreed that this would count for the first marking period, but this section over here would not, would be the bonus section, would not be part of the quiz itself. It's very simple. I mean, look at the questions. I don't think there's, now, I know some of you take shortcuts. I'm not going to take any shortcuts in the video. I still would like to see some of this, right? So I'm going to see you combine or identify the like terms. I mean, yes, it's obvious, you know, that these two are the like terms, and then I'm moving the -6 to the back of the expression. All right, but again, it's just I'm trying to make sure that you see what you're combining. Be careful of who you're adding or subtracting, so that you don't make any mistakes, any silly mistakes. So it's -12 minus a. I'm going to put a 1 here just for a visual effect, just to make sure that I know it's -12 minus 1, and that's -13a. And then -6, right? Nothing else to do. The -6 is a constant. There are no other ones, so we have nothing to do. So just be careful that the terms you're combining starts here at the sign, right? And ends right here, right before the next term. And the next term starts with a subtraction sign. So that subtraction sign does not belongs to the 6. Okay. So likewise here, 14v and minus v. Okay, and I am going to move them around, and then I'm not going to change colors, but I'm going to put these together. -21p minus 8p, and then I'm going to triangle over this one. This plus 9v squared. So in reality, when you actually write this expression, you should write it with the expression with the highest exponent should go first. So that should actually go in the front. So it's plus 9v, and then it's this 2. Oh, I've got to do it alphabetically. Sorry. So I'm going to do this alphabetically. You don't have to, but I'm just showing that in the future you're going to have to anyway. So it's -21p and minus 8p, so you get -29p. And 14v minus v is just simply positive 13v. And that's my expression. Okay. I mean, I can't have an expression where that plus there, it's not in there. So if you actually had this, and I've seen just in general that sometimes students write 9v squared minus 29p and they leave a blank here. There's nothing. And then 30v, you're missing something, right? So don't forget your addition or subtraction sign. All right, so let's start this in order. That's my fault for the previous problem. So the order here would be these two, the k squared and the plus k squared. So I got k squared plus k squared. And I'm going to do the minus 12k. And then the last two remaining are the minus m minus 21m. So that's simple enough. 2k squared plus k squared is 2k squared, right? We add the coefficients, right? We add the coefficients. And then over here is minus 12k. That does absolutely nothing because there's no other like terms. And negative 8m minus 21m. That's just going to give me minus 29m. Super, super easy. Next one, I have an a squared b cubed. Do I? Yes, I do. I have one like term right here. These two are the same type. So it's a squared b cubed minus 6a squared b cubed. And then I'm going to write this guy here, minus 12b5, because that has the higher exponents, and then minus 9a. So the only two that you're going to combine are these two. So that's, we subtract the coefficients. 4 minus 6 is negative 2, a squared b cubed. And then copy the rest. Alexa, what's the temperature?
Right now, it's 32 degrees Fahrenheit.
Oh my God.
Today, expect a high of 42 degrees.
Jeez, winter is here. Early. Distributed property. So again, remember, we're multiplying the term outside times the factor outside times everybody inside. Be careful with your sign. So deal with that first so you don't make any mistakes. So it's a positive 4, right? So it's going to be a positive times a negative, which is giving me a negative. 4 times 7 is 28k. And then a positive times a negative again. So negative 4 times 8 is 32. Ask yourself, can I combine these two? No, we're done. Over here, it's a 1. There's a hidden 1 here. If you want to put it in there, you can. So I know it's a 1, so it's going to be m and negative, I'm sorry, m and 9/8 squared. Just let me remove that because that was a mistake. You just have to worry about how are they going to come out of the parentheses. Are they come out exactly the same, or are they going to come out different? It means the opposite sign. So it's a negative times a negative, so the m, you right away notice, it comes out a positive m. Negative times a negative again, and the 9/8 squared comes out as positive. So that's what happens when you multiply by a negative 1, as opposed to, and I'll do it right away, this problem over here, right? The bottom one, if you imagine there's a 1, that 1 is positive, right? And if you multiply that, everybody inside the parenthesis comes out as they are. Right? That's the difference when you're doing it with a positive number here and a negative number here. Okay. Last one here, not last one, but the next one, again, we multiply the coefficients of 4. So it's a positive times a positive, so it's positive. 4 times 5 is 20. And the x's, right, remember when we multiply numbers or variables that have the same base, we add the exponent. So this is an x, let me put in a 1 there. So x1 times x3, I mean, that literally means this, x times x times x times x. This is the first x, right? And this is an x to the third power, x times x times x. So this is just simply x to the fourth. And that's why we get to the x to the fourth. We can actually make the shorter version, right? We can write x to the fourth. And then y to the second power and y fourth is, again, I'm just going to do this. Y to the second power times y to the fourth power. It's this, right? So using exponents, we make our life easier. We can just write y to the 6, and that's what's y to the 6. Then last one is a positive times a negative is a negative. 4 times 12 is 48. There are no x's, but I still need to write it down. But the y's, right, the same base, and we're going to add the exponents and y to the 5th power. That's it. A little bit of fractions here. Again, these are nice, easy fractions. Right. So 3/5 times 15 is a negative times a positive, so first of all, it's negative. 3/5 times 15 is 9, right? 3/5 of 15 is 9. There is an m cubed and an m here, so that's going to give me m to the 4th and w. Negative times a negative is a positive, and 3/5 of 20 is going to be 12. M to the third power, right? M to the third power here, and m to the second, that's going to give me m to the 5th. And then the w and the p is going to multiply, so I get pw, and I want to write it that alphabetically. Last one, it's a negative times a negative, which is a positive, and 3/5 of 5, that's easy, it's just 3. M cubed multiplies with no one, but still part of the problem, and w is w squared. Okay. So I'm going to actually take these two and do it at the bottom here, so just that you may see it. So I have negative 3/5, and I'm gonna write everything else. So take this, I'm multiplying by this, just for a second here. So it's negative 3/5 m cubed, expand it out, times w, times 20, by the way it's negative 20, times m, times p. And that's what it looks like, and that w looks like the tomato I bought yesterday. Heirloom tomatoes, which I just made a grilled tomato cheese sandwich. Oh, you know what the trick to that is? Put mayo on the outside when you grill it. That gives you a nice brown color. Oh, they're so good. So again, so here's what we have. So it's everything, everybody's being multiplied. If you think about it, times, 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 right? So it's one big multiplication expression. So you would take these two, negative times of negatives, that's positive, and 3/5 of 20 is a 12, which is what we got here. And then we look at the m's. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? That's m times m times m times m, which is m to the 5th. So I'll write that one. So this is out, 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 this is out. Now we're multiplying w and p. Well, so in a way we are just rearranging this to make it a little bit shorter. and putting our variables alphabetically. And that's how I get this, which is what we had. Positive times the negative is a negative. 5/7 of 14 is, I don't know, 10. 10m, sorry. Positive times a negative is a negative again, and that's 5/6 of 35. 7th of 35 is 25. And B. And the last one is a negative again, and that's going to give us 5/7 of 7th is 5 and 5g. Why did I give you that problem? Because it's so easy. All right. Now we're going to do two things. Notice that this is, after a while, becomes repetitive, and you get more and more comfortable. So I get 6k squared. Positive times a positive is positive. 3 times 2 is 6, and the k times k is k to the second power. Minus, sorry, let me do that. Minus 12, because it's negative, km. And then I copy the rest. Plus 12 minus 8k squared. If I have anything to combine, I will combine, which is these two guys here. So 6k squared minus 8k squared. I'll write the rest a little bit further away. That does nothing, and the 12 does nothing. So these two are just going to sit back and relax. So these two now, 6 minus 8 is negative 2k squared. Then I'll copy the rest. And that's my answer. Okay, so again, distributive property is only happening here. These two do absolutely nothing. So 5 times 8 is 40. Positive times a positive is a positive, so 40. The a squared, a fifth, a2, it gives me a7. Positive times a negative is a negative. 5 times 12 is 60. And I'm going to get a fifth times 8. It's going to give me a to the 6th power. Minus 6a7 minus 7a. Do I have anything to combine? It looks like these two fellas here. You can already, I know some of you will already write the answer. It's 34. You can. I'm just, writing it out because it's Saturday morning. And then this comes here, and the minus 7a go all the way back. So the only two that you have to focus on is these two. And we already know that's 34, 8 to the 7, and then minus 60, 8 to the 6, and minus 7a. Will the order, if you wrote negative 7a first, matter? Well, no, honestly, it doesn't. But by convention, we just write it in order. Okay, magnitude. So highest power comes first, and we try to do everything else alphabetically. So it happens here. The distributive property happens here. The 5 does nothing, and the distributive property happens here again. So we have two distributive properties. So we get 2p to the 4th power. Remember, there's a 1 there. There's a 1 here. There's a 1 here. And there's a 1 here, right? If you like to put it in there, just remind yourself, that's fine. And then minus 2p3w. That minus 5, and that will change color. Okay, try that. Will change color. And then blue is a negative times a positive, so it's negative 3p. Don't forget to add here. Negative times a negative is a positive. 3 times 1 is 3. And then we got p squared, w cubed. Are there any like terms here? P4s, no P4s, no P3s. This is a P3W, this is a P2W3, so wow. So I'm just going to make this a little prettier and write it like this. 2P4, right? And I'm going to take this guy minus 3P3 in order. And I'm going to take this guy here minus 2P3W. Oops. Yeah, that's right. And then this guy plus 3p2w3, and then find the minus 5. You don't have to do that, but I'm just saying that that's the order I would have put it in. No, these two would have switched. No. Next. No, don't clear objects. Okay. 16, and again, the distributive property. It's nice if you just put it here so that you don't have to focus about anybody else. 16 of no idea where I got 6. We got 12 minus 6h, and then it's a negative times a positive, so it's negative 4h. And I should switch colors. There you go. 4h, and then negative times a negative is a positive, and 4 times 7 is 28. And then I'm going to change colors again. Change colors again. Just 9h. Do I have like terms to combine? Yeah, I do. This guy, and this guy, they're all h's. So it's negative 6h minus 4h plus 9h. And then we have a plus 12 and a plus 28. And then, so these three, oh, wait. No, they're all h, so I don't know why this should be an h. So negative 6 and negative 4 is negative 10, and negative 10 and 9 should just give me negative 1h, or just negative h. And then 12 plus 28 is just positive 4. Okay. Okay, so I'm gonna have my sandwich. So then I put these, so I know that the distributive property is happening here. And over 9 here, there's no number, so you might benefit from putting a 1. No, that's happening here and here. But 19k, negative is a positive, 14x. Negative is a positive again. Straight. I'll put the negative 9 in different colors so that you know that does nothing. And then it's a negative 1 times k is negative k. And negative 1 times positive 15 is negative 15. So that's what's happened. Like terms? Good card. Sorry. So with that guy, the k's, there's 3 k's here. And then there is an x. Oh my god, why did it not change colors? There's an x here, 14x. Okay, change colors. And then a 14x. And then the last two I'm not going to circle, they're both constants. So if I'm going to do 19k plus 56k minus that k, so all these three are going to be combined with each other. And then I have a 14x that does nothing. And then way at the corner, I'm going to bring the negative 9 and negative 15. So the only focus should be these 3 guys and these 2 guys. Now, 19 and 56 looks like, I don't know, 75 and 75 minus 1. Remember, 76k. Hopefully I am correct. Yeah. No, not correct. No, I am. No, I'm not. No, don't do that. Let's see. 19 and 56. 75. And 75 minus 1 is 74. So that should be 74k. Plus 14x. And then negative 9 and negative 15 is just simply negative 24. Done. Distributive property is happening here, here, and it's happening here and here. Negative 4m. Change colors. With the negative times a positive, which is a negative. 1/3 of 45 is 15. M times m is m squared. Negative times a negative is a positive again. And 1/3 of 12 should be 4. And then km. Right? So this is a negative times a negative gives me a positive. And what's 2/5 of 30, which would be 12? M. Negative times a positive is a negative, and 2/5 of 15 should be 6. km. Like terms? Like terms, like terms. Well, this goes first. There's nobody else. Okay. Are there any kms? Yes, there's kms. There's a km over here, and there's a km over here. I'll put that 4 km minus 6 km together, and then way at the back, I'll put these two fellows. So negative 4m plus 12m. Combine like terms, so that's negative 15m squared. That stays. These two starts here, goes all the way here. It's giving me negative 2 km. And these two will give me positive am. Okay. So there's a negative, there's a 1 over here, right? So it's negative and a positive is a negative, 4m. Negative and negative is positive, and 1 times 9 is just 9k. Plus, and again, there's a 1 here. And hopefully, eventually you'll notice that's not necessary to put that 1. And there is no number outside. If you imagine there's a 1, everybody in the parentheses come out as they are. So the 7k, just we're removing the parentheses, right? So this becomes 7k. Positive times a negative is a negative, and 1 times m is still just m. So that's what I get when I remove the parentheses. Now I'm free to move my like terms next to each other, which is these two. And then the other two, I'll put a little bit, plus 9k plus 7k. Combine these two, I get negative 5m. And then combine these two, I get plus 16k. Hopefully, I did it right. I'll come back to the patterns, do the test items first. Factor. Okay, so this is, again, you can use the, what do you call, ladder method if you like. So, need more room. When was the last time you had a grilled cheese sandwich? Not that often. I don't remember, actually. Should have it. It's nice on a cold day. Soup. That's what I forgot. Soup. Yeah, coffee, but no soup. It's tomato soup or something. So you can do it this way. Helps. Let's factor out the greatest common factor between the coefficients, 21, 36, and 18. It looks like 3. Let's see. 3 goes 21, goes to 36. Is there any number higher than 3? 3 and no, so it's 3. So you want to take out. Now we're looking at the variables. You want to remove. You want to make sure that they all share. So if you look at the coefficients, every single coefficient has a 3 in it. There's a 3 in the 21. There's a 3 in the 36. And the 3 is in 18. That's one of the factors, right? So likewise, you do the same thing. So you want to look at the variables and let's look at the a's. I want to make sure that whatever we take out, that everybody has it. So if I take out a to the second power, there's an a to the second power here. There's 2 a's in here, a times a. Is there 2 a's in here? Yes. And there's 2 a's in here. Now, just for a second, let's say that I take out an a for a to the fourth. I wouldn't be able to do that because in this over here, I don't have 4 a's being multiplied. I don't have 4 a's being multiplied here. The only one that has 4 a's is this guy. So I can't, they don't all share that. So what I do know is that for sure, they all have an a to the second power. Likewise with the b, I want to take out what they share, and they all share at least a single b. And that's what I take out. So now you just got to figure out this times, I'm not going to put that yet. You got to figure out this, so this ends up being that factor outside, and now we're looking for these 3 numbers, right? 1, 2, right, that's what we're looking for. This times what gives me 21a squared b. This times what gives me 36. So that's not that different. So if you divide 21 by 3, we get 7, right? And that's all we need because 3 times 7 is 21. And then a squared b would just follow. So that's part of our first term here. Second, 3 times what? So let me just write this over here. 36 divided by 3 is 12. And think about it. A to the second power times what gives me an a to the third power? B times a. And b times b to what power would give me b to the fourth? It would be b to the third. And then again, some another subtracting sign. And 3 and 18 would be 3 times 6. A to the second times what a would give me a to the fourth would be a to the second. And b times what b would give me b to the third would be b to the second. So write it out. So now your final answer is not this. It's not this. This is not your final answer. This is just a method you use to, what do you call, solve your problem. The final answer is this. That's the expression I'm looking for. Factoring out the GCF to create an equivalent expression. So now you can always double check. Hey, if I multiply these two, does that give me 21 a squared b? If I multiply these two, does that give me 36 a3 b4? And lastly, if I multiply those two, will I get 18 a4 b2? There's b3rd, I'm sorry. There's no way you can walk out of this having this problem incorrect. Because you can always double check. Now, if you don't double check, now that's a different story. So again, 12x cubed y squared z minus 12y cubed z plus 4x squared y. And again, if you want to use this, you can use it. So I want to take a 4. They all share 4. X's. Do they all share X's? No, I can't pull that out. Y. They all do share a y, and the y that they share, they all have a single y in each of those terms. Z's. Do they share z's? No, they don't. So my factor outside is 4y. Now, let's work on the inside. So 12 times 4 is 3. And then it would be x cubed. And y times what's y to the second power? Y z. So that's my first term. 4 times what's 20 is 5. And then the y, they share. So it's y times what becomes y to the cube. So it would be y squared. And I also need to put a z there. Plus, well, 4 divided by 5 is just 1. I'm not going to write that 1. I do need to write x squared. And that's it. So my final answer would be this. yz minus 5 y squared z plus x squared. So, again, take the extra 5 seconds, multiply it out, and just ask yourself, if I do the distributive property, will I get this back? Right? If you do, you're in good hands. This one actually, I won't even use a ladder method. I'll just do it on the side. So I want to take out something. So this is going to look like this, right? So I'm just going to write it. What do they all share in common? They all share the 7. Do they share any variables? No, they don't. So 7 times what's negative 35m? It'd be negative 5m, right? I did these two. I should get that. 7 times what's 14k? It'd be 2k, right? Here's my distributive property again. And the last one would be just a. So if you do this distributive property, will you get this expression? Remember, they should be equivalent, right? Last one. Boo, 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 boo. Well, they all share a 3, right? So I'm just going to go straight for it. They all share 3. They all share an m. Yeah, they all. So actuality, it should be 3m. They all share 3m. So first one, 3 times what's 9 is 3, and then 3a, because 3 times 3 is 9, and ma would be am right there. 3 times what's 12 is 4. They already have an m, so it's 4p. 3 times what's 6 is 2, and that would be 2x. And the last one would be 3 times what's 10. So that's my expression. So again, double check. Make sure you're good. And Oh yeah, I need to put your bonus word. I know. Keep it simple. So it's going to be grilled, if I know how to spell it. Grilled cheese sandwich. Spell it right? Sandwich. C-H-G. Sandwich. Now you gotta make me look up the word sandwich. No, that's right. All right, so that's your bonus word. Spelled correctly, hopefully. Multiply polynomials. So this one, again, think of it as distributed property happening twice. Okay, that's how I like you to look at it. All right, doing distributed property twice. So that's it's always easier to remember, right? So it's 2x squared plus, and 2x times 6 is 12x. And negative 5 in x is negative 5x. And negative 5 and positive 6 is negative 30. Can I combine anything? I can combine the middle terms here. So it's 2x squared. 12x minus 5x is positive 7x, and then minus 30. So that's the answer. These two will go first, right? Doesn't really matter, but just by order. 4ak, 4a times 2k is 8ak. Positive times a negative for the second one is a negative, and 4 times 8 is 32a. Bottom. Negative times a positive is a negative, and 5 times 2 is 10k. Negative times a negative is a positive, and 5 times 8 is 40. Can I combine anything? Absolutely not. So you're done. This one, okay, same thing, not a big deal. So positive times a positive, so I'm going to give you 2x to the fourth, and then x cubed times, going to be a negative first of all, and it's just going to be x cubed y squared. There's a 1 here and there's a 1 here, so it's just 1. The other two, these two, negative times a positive, which is a negative. 3 times 2 is 6, and then xy. And then negative times a negative is a positive, and we're going to get 3, and the y's, I'm going to keep the base, add the exponents, y third. Can I add anything? No. Again, these two first. And just erase this over some room. 2m minus 3m, and we're multiplying those two. It's going to get negative 6m to the second power. 2m times that w in that corner, it's going to be negative first of all, right? Positive times a negative, and then we get 2mw. The second distributed property happens here. Negative times a negative, which is a positive, and you get 12mw cubed. And then negative times a negative again gives me a positive, and then 4 times that 1 here is going to give me 4w to the fourth power. I'm going to rewrite that. Well, actually, I'm not. So that would have been your final answer. No, it wouldn't have been your final answer because you would have to rewrite it in order. Oh, and I'll do that. Oh, jeez. So before that, 4w4, and then I would have probably written it like this. Make sure that if you do move it and write like that, the sign comes with it. Right? So this would be the cleaner, prettier answer. Okay. And now we're back to your favorite. I don't know why you guys don't like these. Well, wait till we start graphing these. So let's see, first difference, and I'm going to write just first D. It looks like a 3, a 3, a 3, a 3. So it's a linear one. Ah, geez. So it's a, what kind of sequence? It's going to be a 3n sequence. And 3n sequence, how does 3n sequence goes? It goes by 3, 6, 9, 12, and 15. Do I have to modify? So I already know that my function or my rule here, okay, my rule or my function, however, is going to be a 3n. Do I have to make any adjustments to my 3n function to get this one? Yes, I do. So for each of the of these, the 3, the 6, the 9, the 12, and the 15, I really want a 6, 9, 12, 15, 18, right? So I need to do a plus 3 adjustment, right? So I have to adjust my 3n sequence, and I have to adjust it plus 3. Likewise, I want you to, if you have time, substitute. So let's pick the fifth term here, the fifth term. If the fifth term comes out to be 18, so if I substitute 3 times 5 plus 3, 3 times 5 is 15, plus 3 is 18, right? So I know that my rule here works. And I'm going to check one more time. Let's check the fourth one. 3n plus 3, and the fourth term should be a 15. So 3 times 4 plus 3, 3 times 4 is 12, plus 3 is 15. And guess what? I got this 15 here. So on the test, I'll probably ask you to give me the, I don't know, 52nd term. What would be the 52nd number on that sequence? And then you just apply your rule and find that number. Super, super easy. 1, 6, so let's see what's here. So again, first difference. Looks like a 5, 5, 5, 5. Are you serious? All right, so this is a 5n sequence. 5n sequence goes by 5, 10, 15, 20, 25. Okay, so that's what a 5n sequence. Now, I don't need a 5, a 10, 15. I need to get a 1, 6, 11, 16, 21. So what adjustments do I make to my 5n sequence to get that? Well, 5n sequence for sure, right, because it goes by 5. So I have to make a tiny adjustment, which is subtract each one by 4. So my function here, the rule is 5n minus 4. That takes, so again, let's check that. For the fifth term, I'm supposed to get a 21. Well, if you substitute a 5 over here, you get 5 times 5, which is 25, minus 4, you get 21. On the second term, I'm supposed to get a 6. So put 2 instead of n. 5 times 2 is 10, and 10 minus 4 is 6. So I do get it. So there's your function, 5n minus 4. And then, let's definitely need more room if it's a quadratic. 6, 7, 14, 34. Okay, so first D, that looks like a 11. This looks like a 17. This looks 17. 7 minus 4 is 3. This looks like a 23. And then this looks like, let me just do 7, 16 minus 7 is 9, and 7 minus 5 is, that looks like a 29. And that tells me that it's a quadratic. So I'm going to take my second difference. And it looks like a 6, a 6, a 6. Oh, thank God. So it is a quadratic sequence, so something that goes n squared, something n squared. And what are we told to do? So we're going to have 6, and we're going to take 6 and divide by 2, and we get 3, and that little fellow is going to be over here. So this is there is a 3n sequence, 3n squared sequence in our sequence. So how does a 3n squared sequence go? Well, if you substitute 1, what do you get? You get 1 squared, which is 1 times 3, and you get 3. If you substitute 2, right, 2 to the second power is 4 times 3 is 12. You substitute 3, right, because we want 3, but the third number is sorry, this is a square. 3 to the second power is 9, and 9 times 3 is 27. We need a couple more numbers. So when it's n equals 4, it'd be 4 squared, which is 16, and 16 times 3 equals 48. Do we have enough? We'll do one more. And then when n is 5, 5 times 5 is 25, times 3, you get 75. So let's write those numbers now. So I get a 3, a 12, a 27, 48, and a 75. So now from here, and I'm going to put an arrow here, I'm going to subtract this sequence from my original sequence. So if I do 6 minus 3, I get 3. If I do 17 minus 12, I get 5. If I do 34 minus 27, I get 7. If I go 57 minus 48, I get 9. And 86 minus 75, I get 11. So I subtracted this sequence from my original sequence, and I'm left with this, because now I have another sequence size, and I have a linear sequence as part of that sequence. So take the first difference again. They're all twos, twos, twos. Look how pretty they are. So it's a 2n sequence, and a 2n sequence goes by 2, 4, 6, 8, 10. Do we have to make an adjustment to our 2n sequence to get what we really want, which was 3, 5, 7, 9, right? If you look at this, and if you subtract, that tells you what your adjustment is going to be. So it's a 2n sequence, but it's going to be 2 plus 1. So we had, for sure, that was this. Now we found out that there is a 2n sequence inside there, too, and with a slight adjustment of 1. So here's my rule. Substitute. Let's just pick, I don't know, fine. Let's pick the fifth number. On the fifth number, does that, the fifth term, sorry, would that equal 86? So the fifth number in our sequence here should be 86. Well, if I use our rule here, I should get 86. So 3 times 5 squared plus 2 times 5 plus 1. 5 squared is 25 times 3, right? And 2 times 10, 2 times 5 is 10. There's a 1 here, I forgot. Plus 1. 3 times 25 is 75. Plus 10 plus 1. 75 plus 10 is 85. And 85 plus 1 is 86. Hey, look at that, it worked. So I can use this to find. So again, on the quiz, I would say, okay, so we have 5 numbers in our sequence. Let's keep on going, right? So if we were to go with a sequence and I asked her, what is the, I don't know, the 23rd number in our sequence? You could use that. Okay. Okay, so what do we have here? First, it's going to be a 9. 13 looks like. And it looks like 46 and 29. 7, 17. And then 67 and 46, it looks like 21. Yeah. So, ready, it's a quadratic, so my second difference is going to be a 4, 4, 4. So we know that's going to be n squared and something n. We're going to take that 4, we're going to divide it by 2, we're going to halve that, right? So it's 2, so the number here, so it's a 2n squared sequence. So how does a 2n squared sequence go? Well, substitute 1, 2, 3, 4, 5, and we'll get our first, 5 number. So 1 squared is 1 times 2, so our first number on that sequence will get 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And 5 squared is 25 times 2 gives 50. So here are the first 5 numbers of the 2n squared sequence. Now, we're going to subtract this, and I'll put an arrow. I'm going to subtract that from that, right? So if we subtract, we do 7 minus 5, I get a 5. 16 minus 8 looks like an 8. 29 minus 18 looks like an 11. 46 minus 32 looks like a 14. And 67 looks like a 17. Oh, look at that. There is a linear sequence inside in here as well. So part of our rule already is this. Now there's a little bit more here that we have to figure out. So again, we have this sequence that we have to worry about, and look how easy that is. It's going to be a 3, a 3, so it's a 3n sequence, right? So a 3n sequence is 3, 6, 9, 12, 15. If you subtract, you'll get what adjustment you need to make. So you notice that if you subtract everything, it's a 2, 2, 2, 2. Well, it's a 3n sequence, and what we really want is a 5. We don't want 6, we want 8. We don't want a 9, we want 11. So what adjustment do I make to a 3n sequence to get to those? We add 2. So it's 2n squared plus 3n plus 2. And I'll leave the checking for you. All right, so we got 2 more. That looks like, again, first D, 5, 7, what is this, 9, 11, yeah? Okay, so, again, they're not different, they're all different, so we need to take the second difference. The second difference tells me that's 2, 2, 2. So it's an n squared sequence, all right? And remember what I told you to do is that 2. We're going to divide that by 2 and put a 1. So that would be just a 1 here. So we don't even need to write that, right? It's a 1 n square sequence. That's just n square sequence. And well, how does an n square sequence go? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, etc. Right? So what do we do next? We subtract our, so let me just start writing this, that our rule, part of our rule is already in an n squared. So we're going to subtract this sequence from this. Let's subtract from that. 3 minus 1 is 2, 8 minus 4 is 4, 15 minus 9 is 6, 8, and 10. Now we have this sequence to worry about. And you can already clearly tell that this is a linear, right? A linear sequence. Goes by 2, 2, 2. So it's I'll put a 2 over here. 2n squared, the 2n sequence goes by 2, 4, 6, 8, 10. Do you need to make any adjustments to this 2n sequence to get to the 2, to get to the 4? No, it's exactly what you want. So it's n squared, this one, plus 2n. And again, if you subtract these two, you get 0, 0, 0. So you tells you that there are no adjustments necessary. So it's a 2n squared plus 2n. Last one. First difference, 4. Wait, 37? 37 menos 9. 17 menos 9 es 8. Me sale 28. Correcto. 65 menos 37. 15 menos 7 es 8. 5 menos 3 me sale 28 otra vez. ¿Qué estamos restando? A ver, perdón. 9 menos 5 es 4, sí. 37 menos 9 es 28. 65 menos 37 is... No, this is the one I made a mistake. I see. All right, so I don't have the 2 questions that I gave you because I have no idea where they are. So I'll end my video there. If you have questions on those 2, the extra 2 sequences, just go to the class website, fill in the contact form, and I'll make a video for those. But just let me know what the sequence is. So on the email, actually write out what the sequence was so I can make a video on it. Okay, and that's that.